Hi everyone, welcome to the channel. If you have never used R before, don't worry, you are in the right place. Today I'm going to show you step by step how to get started with R for data analysis. I'll explain every single part of the code, so even if you have never coded before, you'll understand what's happening. Let's get started. Let's begin from installing the package. That's the first step in R. In R, packages are like extra toolkits. They add special functions and features that are not included by default. Before we can use them, we need to install them. Here is how you install a package. Look, for example, here. Let's break uh, down. What does it mean? Install package, and here the parentheses. It's a function that tells R to download and install a package from the internet. And the name of package you want here, it's Haven. For example, here's Haven, here's psych, and the like. So the name of the package you want here, it's Haven, goes inside a quotation mark, double quotation mark. Don't forget the parentheses around the package name. That's how R works. Every command in R ends with a new line. No need to for a semicolon. Let's do this for all the packages we will need today. For example, for this function for today, I need this package. So you can select and run a code for the package. Let's run. Yes. Okay. Each package has its own name inside a quotation mark. R is case sensitive, so type the names exactly as you see here, with the correct uppercase and lowercase letters. The other is loading this package. After you have installed a package, once you don't need to install it again and again unless you switch computers or reinstall R. But each time you open R, you need to load your package. You do this with library function because the packages are now installed in your computer and you have to load them to here to your R window. This library function, this tells R, hey, I want to use Haven package right now. No quotation marks this time. Look in each of them. Here, when you library them, library Haven, here there is no quotation mark. But when we install, we need a quotation mark. The other, after installing the package and also library them, the others, let's import our dataset. Here, you can import your dataset from any format, from Excel, from Stata, SPSS, from any format you can import your data. Tricks is how we assign or save our output. The symbol means store the result in this form. So we assigned this whole thing for data. You can name anything here in place of data. The other is read data with function. This is a function that loads Stata dataset, for my case, .dta files. It can be any file. So you can copy and paste the file path here. So it reads the function. So the file path where your dataset is stored goes inside quotation marks. You put inside the quotation mark. Be sure to use forward slashes in your file path, not backslashes. Let's run this. Let's select and run it. So it's immediately included in your environment and it's run here. Because I already run it, so it shows me this color. After you run this line, your data is now stored in an object called data. You can name this object anything you like, but data is a common choice, as I mentioned earlier. So in place of data, you can write anything that you want. The other part here is selecting some variables for the analysis. So we select specific columns. Sometimes datasets have lots of columns, but you might only need a few of them for your analysis. So let's see how we select and give an object name for that. Here we give an object name, selected vars. Here also you can give any name for your selected variables. And this means it stores our selections in any object called vars, selected variables. The other is data. I think you are familiar with it. Here it's we assigned data. Data means our data set. We assign that. So every time we don't need to write this social media use and mental health data set like that. So only when write data, our R understands data means this the whole data set. So it starts by looking at the data we loaded earlier. So here data, selected variables. It looks inside the data and then let me explain what this means. The comma tells us we are interested in columns, not rows. And C with function this parenthesis. It stands for combine. It creates a list of column names. So here you write a list of your column names you are interested in to work. And for each variable, each column name goes in quotation marks and separated by commas. And also the closing here, the opening and also closing with this mark. So that tells the R to finish the selection. Now the selected vars contains just the 4 columns we picked. The other, we imported our datasets. We also selected some of the key variables for our analysis. Let's see the descriptive statistics here. Let's quickly explore our selected variables. We will use 3 different functions for that for now. Summary of those selected variables, describe those selected variables, and also scheme. Here is what each one does. Summary statistics. Let's run that column and see. Look here at the end. It gives basic statistics like minimum. Look here, minimum, first quartile, median, mean, third quartile, and maximum. Those are descriptives. It gives some additional importance, like here, and the missing values. How many distinct values are there? Here's 13. The mean, median, Guinea, 5%, 10%, 25% until 95 percentile. Gives also that with the values and proportions. The other, let's see, scheme. Here's also, it has the mean, standard deviation, and the percentiles. Also with histogram. That's also a nice part of that. I really appreciate that. So you can use any of them, or you can check many of them. The other is normality check. Let's see normality. Because in statistics, normality is very important. Many statistical terms assume data is normal. That means it follows a bell curve. Let's check if our data meets that assumptions. You might use histogram, for example. Let's run this code. Right. Look here. Here the plots. It gives the plots here. Let's also break the code. What does it mean? Histogram with the function, that's with a parenthesis. It makes a histogram with this bar plot of your data distributions. So this hist and the function, the parenthesis, and main. Here there's a main equals. It sets the title in a quotation mark. So you add a title. If you don't want that, you can delete it, but it helps histogram of identity total like this. And the other is call inside call. It changes the color. Here sky blue, we write sky blue. And the other is probability is equal to true. Here we said probability is equal to true. That means the area under the bars adds up to 1. So you can add density line. And the other is lines. Here there is lines. It adds a red. This one, it adds a red. Smooth density curve over histogram. Any color. You can make it black, for example. Let's run it again. Look. So you can write any color there. And also here there is 2. That makes the line thicker. Let's make it, for example, 3. When increase the size, the number, the line is thicker and thicker. Like this. Okay, good. Let's go to QQ plot. Let's run it, and we'll break what does each of that mean. QQ line, here there is QQ norm. It creates a QQ plot, here QQ norm. It creates a QQ, quantile quantile plots, which helps you visually check if your data is normal distributed. That means whether it follows this line, red line. It helps to check whether your distribution is normal. The other QQ line, that's a red line, that's a red reference line. If your data points mostly fall on this line, your data is close to normal. Also, you can change the name of this, the color of this line. Let's make it also black. If you make it black, look, blue. Sure. The other is skewness and kurtosis. This var, we are saying assigning code, creates a list of the variable names we want to check, vars, to check for which variables. So it creates an object. For the loop, goes through each variable name one at a time. Here we are looping them. That means for a loop means it goes through each variable name one at a time. And the other is cut here. It prints out the text to the console. And the other skewness here, cut skewness, and also kurtosis is a function calculate for each variable how much the data is lopsided, that means skewness, or pointy or flat, that means kurtosis, compared to a normal curve. And let's run that to the end. Great. Look for each variable. There are skewness and kurtosis for depression, for self-esteem, for anxiety, and also for ADHD. So the loop function helps to include all these variables together. The other is Shapiro-Wilk test. It checks if your data is normal mathematically. Let's run Shapiro-Wilk test. Great. For each variable, it generates the p-value of Shapiro-Wilk test. And if you are interested to know in depth about that, I have a video on normality assumptions. Please check that video. Usually, if the p-value is less than 0.05, your data might not be normal. But with large samples, almost everything shows up as not normal. So always check the plots too. If you are only relying on Shapiro-Wilk's test, you may commit a mistake. Because when the sample size increases, the p-value become normal. The other, let's see a correlation analysis. This is a relationship between the variables. Now let's see if our variables move together. Do people with higher ADHD scores also have a higher anxiety? For example, that's called correlation. Let's see. Let's run and see correlation. Okay, here it is. The person's correlation coefficients are here generated. ADHD with anxiety is 0.62, with self-esteem 0.36, with depression like this. The first one is coefficients, and these are the p-values, results of the p-values. So let's break the command. What does it mean? So here it says core matrix. You can write anything as you wish. So core matrix saves your results in any object called core matrix. Here we have correlation. Also, you already, I think you remember that you selected variables. The other here, there is use equal to complete dot ops means it ignores the missing data without missing data. So we are saying that ignore the missing data. Missing data management is one of the most important part in data analysis. And also, I think in my previous videos, I touched that several times. So in this, for example, let's ignore the missing values. And the method is Pearson. Here, you can do also Spearman's correlation if your data is not normal distributed. In our case, it's normal distributed, so we use that person's correlation. The other is here print. It displays the result. So in R or in other softwares also, other programming languages, so is Python. When you print, it gives the result. Here is also there is as.matrix. It makes sure your data is the right shape for the function. And the select vars, we have seen that. We already selected 4 variables, type still Pearson. And we say print core results with R coefficient, just print with p values. That's correct. The other is, let's see, correlation plot. Wow, it generated an amazing, beautiful plot here. And also let's break what does each of that means. Corrplot, it creates a chart with numbers. Look, a chart with numbers showing the strengths of each relationship. Here, for example, ADHD with anxiety. Each variable with itself, it sets perfect correlation. That's one. For example, ADHD with ADHD 1, anxiety with anxiety 1, self-esteem with self-esteem 1. That's the strengths. And also look the color. When it's closer to positive 1 or negative 1, it's somewhat deep colors. And the others are some light. So it shows ADHD, for example, with anxiety, it's 0.62. It shows the strength of the association as well as with the color. For example, ADHD with self-esteem, it's 0.36. Look the color, it's somewhat light. Here the method is number. Put the correlation values in each box. So you write the number and it puts its value in the box. Type upper, use only the upper half of the matrix and no repeats. No repeats. Let's try lower. You You can also write like this, the lower or upper. The other, it is here tail.cx equals 0.8. Change the text size in the levels. That's great.